Lesson 104 is called Triangles. It's about classifying names of different triangles and even figuring out angles that we don't know for different triangles. It'll be very helpful in future geometry-based lessons. Again, a nice little break from the algebra here to try things with shapes and angles, and there will be a little bit of calculation as well. We name the triangles you see in front of you right now, we can name them by their angles. First, the top left. What do you think is the most important angle of the three? It's going to be this one right here. What does that measure? 90 degrees. What do you call an angle that's 90 degrees? It's not wrong, it's right. So we can call this a right triangle. Over here, I have two acute angles, and then there's an angle right here that you don't have to have in a triangle, but this special triangle does have one. It's over 90 degrees, and what do you call an angle that's more than 90 degrees? Obtuse. So we can call this triangle an obtuse triangle. Finally, if we measured these three angles, they would all measure under 90 degrees. Since there is not a single obtuse angle present, what do we call those angles? Acute angles. So it's an acute triangle. I challenge you to create a triangle that has more than one obtuse angle. It's impossible. So therefore, even just one obtuse angle makes it an obtuse triangle. But just to have all acute angles you need for an acute triangle, but only one for obtuse. So keep that straight. We can also name triangles based on lengths of sides. Over here we have a triangle where if you measured each side, none of the sides would be the same. None of the sides would be the same. How do I show that sides are not the same length? Use these tick marks, right? First, one tick mark stands for one measurement. This tick mark stands for another. And this one says we even have another measurement. This is the longest side. This is probably, these are close to the same size, but they will not be the same size. So we call this, for some reason I've always had an easy time remembering this word because you don't use it anywhere else. Pronounce that word scalene. It's a scalene triangle. Over here we actually have two sides the same, and again another word that we don't really use very often, so it's easy to remember. Have you heard this word before? Isosceles. Easier to remember than it is to spell. Isosceles triangle. And finally, this, does it look like any sides are different? We could show all sides are the same by using tick marks like that all match up. And this one you may know, they're equal, so they're equilateral triangle. For this one, you could expect all angles to also be the same, and we can show that by doing this. If two sides of a triangle have equal lengths, the opposite angles of these sides have equal measures. If two angles have equal measures, the sides opposite these angles have equal lengths. What does that mean? It means that if this side is this length and this side is this, and they're the same length, that means that this angle and this angle are also equal to each other. Angles opposite equal sides have equal measures. This is not considered opposite. It's out on its own. It's opposite this side, and nothing can be said about it. Over here, of course, all of them match up. Over here, none of them match up. Therefore, we don't expect any of these angles to match up either. We can find the measures of angles based on something we know about triangles. What do we know about the measures of angles of a triangle? We know they always add up to 180 degrees. Therefore, if I told you that this angle were a 45-degree angle of the right triangle, what are we going to say about this one? 90 plus 45 plus x is 180. 90 plus 45 is 135. What do I need to get to 180? I'm going to need another 45 degrees. And that's going to become a memorization thing. You're always going to recognize that if I have a 90 and a 45, the last one's always 45. Because 45 plus 45 is 90, and divide 180 by 2, and that's 90. right? Over here, let's say that the obtuse angle is 100 degrees. We can't finish quite yet, but what if I told you these angles are the same? Then could you tell me what are the measures of these angles? What does that algebra look like? I said we might get a little bit of calculation, and today we could say, well, I know every triangle angles add up to 180. And one of them is 100, and we have two x's here. We'll call them both x because they have to be the same. I can show that another way and just say 100 plus 2x is going to be 180. How am I going to solve for this triangle? 180 equals 100 plus 2x. Take 100 from this side and this side, so I only have 80 left, equaling 2x. And you can already tell this is going to come out to 40 degrees. So each of these are 40 degrees. Take a look at example 104.2 on page 323. That looks to be perhaps a scalene triangle. So we can look at this one as our example. One angle is 50 degrees. One angle is 45 degrees. What's the last angle? You can use subtraction too. 100 minus 50 is 130. 130 minus 45 is, let's see, 120 is that 85? So you can use subtraction based on the fact that I know all triangles drawn correctly are 180 degrees. You can just take away from 180 degrees. Remember also that angles opposite equal sides are equal, and sides opposite equal angles are also equal. So if you look at practice C and practice D on page 324, first of all, you get practice with labeling triangles and labeling angles. But you have to classify the triangles based on their sides, and then even in letter D, you're going to have angle M being 50 degrees. So what are the other angles? Well, you know, since if this is 50 and these are equal, that means these are equal, which means you can take 180, take away 50, and then you've got 130 left. And 130 is going to just simply be divided by 2. Why? Because these are equal measures too. So what is 130 divided by divided by 2? Well, I guess I'll let you get that for yourself. Final fun fact question. What is the measure of the angle of any equilateral triangle? Doesn't matter if it's massive or if it's, you know, this big or if it's real small. It's always x plus x plus x, right? Because we're talking angles, and angle measures don't change based on the size of the triangle. So these will always be 60 degrees. All right, so to finish up today, you've got all the practice problems. I pretty much did D for you. Test tomorrow, so don't worry about a problem set until Monday.